So our objective is I can solve systems of linear equation by elimination. This is the third method of solving systems of linear equation. All right? So we don't need a Fermat model because we already know what systems of linear equation look like and the definition, right? Just in case tomorrow we have a pop party, I'm filling in a Fermat model by yourself.
Oh.
So the definition is what? What would you say?
Two or more deal things.
Two or more deal things?
Two or more variables.
Two or more linear equations with one same variable. All right? And of course, examples, non-examples, hashtag. Okay? All right? So, at the bottom of your summary section, right above it, write this question down. Question. What is the most important step when solving by elimination? What is the most important step when solving by elimination? Right, because you're going to fill that in by yourself once we do the lesson, right? At the top, I want you to write steps, and once again, I'm going to get you guys started with the steps once we're done, and we'll fill that in. But we start with the first example in the back of your paper, example Q. Yes. Here we go. Example Q says, solve the system by elimination. System given, x minus y equals -1, and 4x plus y equals 6. Copy that. Example Q says, solve the system by elimination. X minus y equals -1, and 4x plus y equals 6. All right. Connie, can you hit the lights, please? Thank you. All right. Writing utensils down, look up to the screen. I'm going to go ahead and do a think aloud for this one. And once again, please stay focused. Please, pretty please. Here it goes. Writing utensils down. Writing utensils down. All right. Here it goes. So, it says, solve the system by elimination. Okay, I know how to solve the system already by graphing and also by substitution. But now they want me to solve it by elimination. What do I know about this method? Well, I know that it's also called combination or addition. Well, that gives me a clue, combining these three, because they don't give me anything else. So if that's all they gave me, then I'm going to use this information to start. Let's see. Addition.
Oh, that's how you do it. X equals 1, let's go.
All right, before I continue, talk it over to your neighbor, see what just happened there.
She just did the addition work back there. You can get out of the bottle.
Here, borrow mine and then I'll get your number. Yes. All right. Okay, writing utensils down, look up to the screen. Here goes the next part. So up to right there, we're okay. Next. Then I can just do this, and I'm there.
Why'd you wait for this?
Hold on. We'll discuss that at the end. Okay, are we there so far? Okay, now at this point, your noodle already knows what to do with that value. Tell your neighbor what would be the next step, please. All right. Some of you, I heard some of you that you wanted to substitute this and this one, but others wanted to substitute it in this one. Does it really matter? No. So I'm going to use the top one for right now. X minus y equals negative 1. What's the invisible number here? And step 5 is always write your coordinates. So this is 1, 2, and of course step 6 is check. Copy that, please.
That's legit.
And I know some of you are saying, Mr. Q, how come you didn't give us this one first? Because if I did, all of you would just be using this and wouldn't want to learn the other. Bam, from the corner. All right, here we go. So, do we know how to check? Yes, let's write the equation side by side. X minus y equals negative 1, and 4x plus y equals 6. What are the values for x and y? 1 and 2. So 1 goes here, 2 goes here, 1 goes here, 2 goes here. Bring everything else down. Minus equals negative 1. 1 minus 2 is negative 1 equal to negative 1. Is that true? Yes. So we're done with that one. Bring down the 4 plus equals 6. 4 plus 2 equals 6. Is 6 equal to 6? Yes, that's true. If it's true for both, then we write solution.
That's amazing.
All right. Copy this next one, please. Example super Q. Example super Q. Oh. The system of x plus 2y equals negative 1 and negative x plus y equals negative 5. Once again, listen to what I'm about to say. Trust the process that you just learned. See if you can do this one completely by yourself. Ready? Copy that and go. All right. Alyssa, get me started. What do I do first? Combine the two. So then I draw a line and I put a plus sign right here. And tell me what to do from there. Cancel out the x. And then? And I get equals. Hands if you got it to right there. That is correct. Next step. We solve for the remainder, yes? Divide by 3, divide by 3. Y equals negative 2. Hands if you got it to right there. Good. From there, does it matter which one I use? No. So I'm going to use the
First one.
Okay, the first one, x plus 2y equals negative 1. So I'm going from here to there. So this becomes x plus 2 parentheses equals negative 1. And instead of y, what goes there? Negative 2. So therefore, x minus 4 equals negative 1. Plus 4 plus 4, x equals 3. Hands if you got it to right there. Step 5, 3, negative 2. You write your coordinates. And of course, we do what? Check. And for right now, I'll let you do the check on your own. And then afterwards, you write solution. Are we there so far? Okay. Hold on. Let me see. All right. Really quick, before I continue, show me the fingers how comfortable you are with elimination method. 5 fours, 5 fours, 5 fours, 5 fours. 2, 3.5, 5, 4 tenths. Okay, thank you. All right, so now let's recap. Look up, please. We started with this one. Look up. And this one we were able to combine or eliminate the y. Look up. We eliminated the y. For this one, we were able to combine and eliminate the x. So before we get to that step of eliminating, there's certain things that need to be in place. Let me go back to the previous one. This one looks a little bit like that one, doesn't it? Okay, so before I move on, what things need to be in place before we eliminate? Talk it over your neighbor. What things need to be in place?
The variable.
Okay, I heard some of you, number one, you said that the variables need to be aligned. Who agrees with that? Okay, that is correct. Also, I heard some of you talking in regards to that the numbers by itself. In other words, they isolate the constant. Who noticed here that the constants are by themselves, and this one the constants are by themselves? Everybody see that? Okay. Also, one very important thing, look up, for me to be able to eliminate what needs to be true. Talk it over to your neighbor, please.
One of the two variables will have to cancel out each other.
Marco. When they're lined up, one variable has to be negative and the other one has to be positive, or in other words, they need to have opposite coefficients. Is that correct? And that's how they cancel out. Yes.
But what if you have like, say, like 5 and -3?
Then they don't cancel. Then that's why we said opposite coefficients. The coefficient here is 1. What is the opposite of 1? -1. The opposite is here, the coefficient here for y is -1. What is the opposite? +1. That's why they are able to eliminate. All right. So now that we got that, copy this one. Example super duper Q. The system. -x equals y plus 4 and y minus 2x equals 5. Okay, now before you start solving, you're just copying this. You start to notice that this one looks a little bit funky. Don't say anything out loud. Keep it to yourself. This one looks a little bit different from the others. Let me go back to the others. Look at this one. Look at this one. Now look at that one. Tell your neighbor the first thing you would do before you start eliminating. What would you do for that system before you start eliminating? Alright, let's see. I heard some of you say isolate the constant, okay, but what specifically shall I do? Helena. Put the y on the other side. So this y, you want it on the other side? So what do I do? Minus y minus y. I'm going to write it underneath. So what's on this here? -y. Bring down the -x. Bring down the equal. And what's left here? 4. Hands if you agree with that. And do you know what to do from there?
Yeah.
Finish it off, please. Go. Copy that and finish it off. All right, check with the neighbor, see what they got. What? Oh, no, she got it?
No, she said for Washington now.
All right. Here goes the rest. Ready? Eliminate the y. We're left with -3x equals 9. Step 3, solve for the variable. x equals -3. Hands have got it to right there. From there, step 4, substitute this into one of the others. I'm going to take the top one, y minus 2x equals 5. Well, but instead of x, what goes there? -3. Bring everything else down. Y minus 2 equals 5. So what is -2 times -3? +6. So therefore, -6 minus 6, y equals -1. Solution, -3, -1. Hands, have you got that? Let's go from the corner. All right. What? No, we're good, right? Well, guess what? Now we need to write our steps. Go back to your Cornell notes. Here we go. Steps. Here we go. Step 1. Okay. I said that step 2 was elimination, right? Eliminate variable. But in order to get to that step, what were the prerequisites? Luker. That is correct. And Luker from the corner. Isolate the constant. That's one thing. Isolate constant. So that means the constant needs to be by itself. What else needs to be true? What did we say? That they needed to be what? Align variables. And I heard over there, what, Ethan? What? That's a line. That's a line. Okay. What else needs to be true in order for us to go to eliminate? Yes. Variables need opposite coefficients. So if one coefficient is -2, the other one has to be what? +2. If one coefficient is 1, the other has to be what? -1, and so on and so forth. So that's 2 steps. Well, that's 3 within the first part, right? So, eliminate. Once we eliminate, what did we do here?
Substitute.
No. What did we do here?
Solve.
Solve for the variable.
Then you substitute.
That is correct. Step 4. Substitute and solve for the second.
Order pairs.
Step 5, write your ordered pairs. And just then, write order pair. And number 6, check. And let's go, yes. Solve for the variable. So clear?
What page is it on? 309? It's page 309, right?
Substitute and solve for the second variable.
Page 309.
No tutoring today. I have a faculty meeting. So, let's see. Home play is solving the 3 systems 3 different ways. And problem number 12 from page 309. So 3 different ways. How many ways do we know now? Graphing, substitution, and elimination. Yay! And number 12 from page 309, that one is a word problem. You don't have to do that one 3 different ways. The only ones that I want 3 different ways are A, B, and Q. Yes. Number 5 says write the coordinate. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.